Hello, this is John from caveofprogramming.com. In this tutorial, we're going to take a look at lambda expression parameters and return type. So we'll construct a simple lambda expression here. Let's say I'll call it pgreet, and I'll set that equal. So we need the square brackets with lambda expressions. We need the round brackets. Let's put in round brackets, and we need curly brackets as well. So in the round brackets, we can actually put parameters. They're just normal. It's a normal separated list of function parameters. So as an example, let's have string name in here, and I'll put my code in the curly brackets as before, and let's say hello and output name and endler. So this is a valid lambda expression. This is a comma separated list of parameters, just as you might expect with any function, and we can call that like this, as we've seen. So that works. Just because function pointers are something that is often confusing. What did I do wrong there? I forgot the actual name. Let's put in Mike. Let's construct a function that accepts that lambda expression and invokes it. So let's have a void test greet. So that's going to accept a function pointer, and we're going to pass a lambda expression to it, and we're going to run the lambda expression. So what should the type of this be? Well, again, we've got a void return type here. There's no return statement. Nothing's being returned, so that's void. Let's give it a name. So we need star because it's a function pointer, and let's call it, I'll just call it greet or whatever. And then we need two round brackets after that, and we need to specify the parameters in there, so it's just string name. We could even just put string in there. That would also work just fine, actually. Let's just use string. Then we can call it, so we can call greet and pass in a name. Let's say Bob, like that. So that's going to work. Let's say test greet p greet, and just run this. I call it pgreet because it's kind of like a pointer, but it's not really, but it's like one. So I just had a spelling, like a typo there. Let's run this. So we've got hello Bob, so that works fine. And again, we could literally just paste that directly in here if we wanted to. That would also work. We don't have to store it in a variable and pass the variable. We could literally put the lambda expression right there. So it's worth trying that if you haven't already. What about return types here? Let's create an I'll call it p add, and we'll set that equal to a lambda expression. So we need the square brackets, the round brackets, the curly brackets. So here we want to take in like two numbers that we want to add together, let's say, or maybe divide would be a more interesting example for this, actually, for reasons that you'll see in a minute. Let's add in two numbers here. So let's say double A and double B. So what this function is going to do is it's going to divide A by B. So we can say return A divided by B, like that. So this is a valid lambda expression. We can call p divide and pass in two numbers there. Let's pass in, let's say 10.0 and 5.0. So we expect to get 2. Now we've got a return statement in there, and it's returning a double because we're dividing a double by a double. It's going to return a double. So C++ can infer the return type here. There's no need in a lambda expression to specify a return type, and we can actually output here. We can output the return value of divide. So let's run this and see if it works. So we get 2. Now this is fine as long as you've only got one return statement. If you've got multiple return statements, C++, well, if they return differing types, C++ can't infer what the return type should be. So let's say if b equals 0, we don't want to try to do a division where the I think you call it the divisor, the denominator, where that's 0, because that would give us an infinite result. So let's say if b is 0, return 0. Let's try compiling that. Project, build project. Now we get an error. Why have we got an error? Because here we're returning an int, and we might think, well, this should be cast to a double. It's pretty simple. But the fact is we're returning an int here and returning a double here. C++ can't infer the type. We have to explicitly specify the return type. And we can do that with the trailing return type syntax that we've seen previously. So after the round brackets that specify the function parameters, they could also be empty, of course, we put an arrow, which is like a hyphen, and it looks like a greater than sign. And we put the return type, which we're going to say is double. This is the trailing return type syntax, which we've previously seen. Now if we build this project, then this works, so we can run it, and it works. We should just check that the code actually makes sense. Let's try passing this in. So we make b 0, and we expect to see it return 0, because that's what we said it should do. And just for fun, because function pointers are a little bit tricky, let's define a function that accepts that. Let's call it void run divide, and that's going to take a function pointer. So what's the return type of this function pointer? Well, it's double. Now we put round brackets in. Well, we're going to have to put star. What name are we going to give it? Let's call it p divide. Or just divide, really doesn't matter. We can put anything in there as long as it makes sense. Then we have round brackets with the parameter list, double A, double B. And then we can call in here divide, like that, and pass in whatever we like. Let's pass in 9 and 3, so 9 divided by 3. We're going to get a return value from that, so we could do something with the return value. Let's say double rval, return val equals this, and well, of course that could be auto as well, and then let's output it just as a bit of variety instead of outputting it directly with cout like we've done down here. We'll just actually go to the trouble of creating a variable. So let's check that this works. Let's say run divide and pass in p divide, and now we can run this. And we should see 3 down there, and we do. We see 3, so that's working. Okay, so that's it for this tutorial. For an exercise, it's good to define lambda expressions that take parameters. They take parameters just like normal functions. There's nothing really tricky there. And try creating a lambda expression that returns multiple different things of different types, like this kind of thing, and check that doesn't compile, and then explicitly specify the return type with a trailing return type syntax like this, and check that works. And it's also good to create a lambda expression that takes parameters and returns something, and check you can define a function pointer that matches that expression. So try creating a function like this that runs the function pointer that you pass to it, and then try passing in a lambda, just as I've done here, because it's worth making sure you're really fluent with these function pointer expressions. We are going to take a look at a bit of an easier way to specify parameter types for lambda expressions, but I think it's important to understand the kind of most basic form of doing this, which is using function pointers. Okay, so until next time, happy coding.